Okay, so you're now into the solving problem part of this deck toy. And so, what we've done is we've created some videos to help you with some of these problems. The first set was just finding a missing side length, and that's pretty simple, pretty straightforward. This next part, which is calculating dimensions, can be a little bit tricky, but once you see a couple examples, you shouldn't have too much of a problem. And so let's just do a quick reminder of dimensions. Dimension is just a measurement of length in one direction. So it could be length, base, height. Um, when we're talking about the dimensions of a room, you're looking at the base and the height, which in some word problems they'll say length and width, which it's still the same thing. It's just sometimes they call them base and height, and sometimes they call it length and width. So here are two problems that we're going to do together. This is the first one. So in this case, they're giving you the dimensions on the blueprint, and you have to find the actual dimensions of the room. And so on George's blueprint, the dimensions for his living room is 3.5 centimeters by 5 centimeters. The scale that's being used is 1.5 centimeters is equal to 6 feet. So what are the actual dimensions of his living room? So here's our key piece of information. Okay, this is the scale that they use. And so remember in the beginning video when we did our notes, you always write it as, and I'm just going to write it real quick. It's going to be model over actual equals model over actual. And I'm going to abbreviate that. Okay. So the first ratio that is given, that's going to be the one that's going to help us solve, is 1.5 centimeters over 6 feet. Okay. And so if you're comparing centimeters to feet here, going back to proportions, you have to do centimeters to feet here. And the first one they give us is 3.5 centimeters. So we're going to put that right here. And we're solving for the actual. Now, because there are two dimensions, we actually have to do two proportions. So I'm going to do the other one over here. We're going to use the same scale, right? Model to actuals, 1.5 centimeters is equal to 6 feet. And remember, all that means is that if I'm measuring on the blueprint, every time I measure 1.5 centimeters, in reality, it's 6 feet. Okay? And so I'm doing centimeters to feet here. I don't know what the actual length is, and so this is going to be 5. Okay? Now, in this case, I'm going to solve this using the cross multiplying. So I'm going to do your 6 times the 3.5, which is 21. Then you're going to do your 1.5 times x, which is 1.5x. And to solve for x, this is a one-step equation, right? You have to get x by itself. The opposite of multiplying is you're going to divide both sides by 1.5. So x is equal to 14 feet. So that's the dimension of the first living room. And so let's do the second one. In this case, 6 times 5 is 30. 1.5 times x is 1.5x. Divide both sides by 1.5. And x is equal to 20. And when you write your answer, when they're asking for dimensions, you want to put it as 14. You do the smaller one first. 14 feet by 20 feet. And that's your answer. So really the only difference in a dimension is that you have to do two proportions because you need both measurements, the length and the width, or the base and the height. Okay? All right, so let's do another one. So here's the second one. So it says the dimensions in Rachel's bedroom is 12 feet by 14 feet. What would the dimensions be on a blueprint if the scale used was 3/4 of an inch or equal to 3 feet? So again, there's my starting point. So here's the scale they gave us. The model is 3/4 of an inch is equal to 3 feet. And in this case, they're giving us feet, right? Because if I do inches to feet, I have to do inches to feet over here. So the 12 is actually going to go in the denominator. And then here's my second one. So again, 3/4 of an inch is equal to 3 feet. And so inches to feet. I don't know what it is on the blueprint, but I do know the actual dimension is 14 feet. This one I don't have to cross multiply because I see this. Look, I can go this way, right? I can increase this by a factor of 4. 3 times 4 is 12. So on this side, I'm going to do the same thing. I'm just going to take 3/4 of an inch and times it by 4. And in this case, x is going to be equal to 3 inches. This one, I'm going to do the cross multiplying. 14 times 3/4 of an inch is 10.5. 3 times x is 3x. And then I'm going to divide both sides by 3. And so x is equal to 3.5 inches. So the dimensions on the blueprint would be 3 inches by 3.5 inches. And that's all you need to know. Like I said, it is fairly easy. It's just you have to do 2 proportions because you're basically finding 2 side lengths. And so remember, the most important thing, setting up your proportions correctly, making sure you do model to actual, and do the multiplying and the dividing correctly.